One of the most simple and effective additions you can make to a model steam locomotive is to add a flickering firebox. And this can be made to work for both DCC and DC. First of all, there is a disclaimer. The body of the locomotive must be removed, which is not always that easy. And unfortunately, you often find that there are some hidden clips only when you break them. So please beware. Next, we need to ensure that there's sufficient clearance behind the firebox door to avoid fouling the motor. Also, it involves drilling holes in the loco body. Finally, soldering close to a plastic body is not for the faint-hearted. Great care must be taken not to get so close to the plastic body as to cause damage. Let's look at the DCC version. In this case, the model I've selected is a Hornby King class. Having removed the locomotive body, the first thing we have to do is to drill a 3mm hole right in the center of the firebox door. I'm doing this using a pin vise, and for accuracy I'm starting with a 1mm drill and working up to a 3mm drill. The pin vise is ideal for this type of work. It's very precise, and because it's very slow turning, does not eat up the plastic as a powered rotary drill would do. And here we have the 3mm hole in the center of the firebox door. I'm now taking a 3mm flickering LED, which is orange. Orange is the color closest to representing the temperature of the firebox. You can see I'm creating a flat on the bullnose end of the LED using a Dremel. You can skip this stage if you wish, but it makes the fitting easier in that the LED is less likely to protrude through the hole made in the firebox door. If you do decide to create a flat on the LED, wear a mask, as there will be particulates coming off. And secondly, do not take too much material off, otherwise you run the risk of damaging the LED. Having created the flat, we will now test the LED to make sure it's still working. And here we have the LED secured with a drop of super glue into the hole created in the firebox door. It's advisable to double check the clearance at this stage to ensure that there's no possibility of the leads coming into contact with the motor. At this stage we need to check the decoder specification for the function wires. As all decoders tend to be different, you'll have to check the specification for your own decoder. Blue is always positive, common positive for all decoders. Now in this case, for this particular decoder, Green is a function wire. You'll notice that on the green wire I've attached a 3.3K resistor. The reason for this is that the auxiliary function from the decoder is 12 volts. Therefore, we need the 3.3K resistor to act as a dropping resistor for the LED. Having relocated the body onto the chassis, let's take a look at the end result. This decoder has the option of the sound of coal shoveling while the firebox is illuminated. Now let's take a look at a DC version. In this case I'm using an 040 Hornby tank loco. Up until this point, the procedure is exactly the same as for the DCC model. And here we're just rechecking the clearance to ensure that there's no possibility of the LED fouling the motor. A bridge rectifier is necessary to ensure that we always have correct polarity on the LED regardless of which direction the locomotive is traveling. And so we have the red and black wires coming from the positive and negative of the bridge rectifier to the respective terminals on the LED. And I've also included a 3.3K dropping resistor. Here we are connecting the alternating side of the bridge rectifier to the motor terminals. It does not matter which polarity of the motor terminals you select. Once again, let's look at the finished item. You'll notice that the loco has to be running before the firebox will illuminate, and that's simply because the LED needs to have just under 3 volts from the track to illuminate, and 3 volts will of course have the loco running. You can try experimenting with the 3.3K resistor by reducing it slightly. That may help to bring on the LED slightly sooner. As a point of interest, the only time you'll see the firebox door of a real steam locomotive open is when the locomotive is idle, such as in a station, or on the road when the fireman is adding coal. The fire receives air from 2 separate sources. Primary air, which comes from beneath the fire bars and is controlled by dampers, which are adjusted by the fireman, and secondary air, which comes from the open firebox door. The 2 sources must be carefully balanced. When the locomotive is working hard, air is drawn rapidly into the firebox, and too much secondary air can cause problems. As cold air is drawn in through the firebox door, it can sweep the hot volatile gases through the boiler tubes before they have completely burned and released their energy. This is wasteful and also results in black smoke at the chimney. Cold air hitting the red hot metal of the boiler tube plate can cause distortion and serious damage. A wise fireman balances primary and secondary air based on the needs of the locomotive. And finally, let's take a look at how effective a flickering firebox can be on a nighttime scene of a model railway. Here's the train now departing.